안녕, hi everyone. I'm sure you already completed the absolute value definition graphic organizer, and I'm just going over briefly so you might check what is a missing piece from yours. The absolute value of a number is its distance from 0 on number 9. For example, if we have a number 9 and then the middle is 0, that's 1, 2, 3, and so on. On the left side, -1, -2, -3, and so on. So from 0 to 3. So that will be 1, 2, 3 units, right? The distance from 0 to +3 is 3. What about the distance from 0 to -3? So that's also count 1, 2, 3. It's a 3 unit to the left. As you already know, distance is always a positive value. And the denoted of absolute value with these vertical lines on both sides of the numbers. So let's say if we put -3 with the absolute value symbol, it will come out as a 3. Of course, positive number will come out as positive. Let's say absolute value of 5 will be just same as a 5. The 5, the solid vertical bar on your keyboard is usually used to indicate absolute value. Right here, I usually say like 2 chopsticks. What are the non-examples? We can have just any negative number, or if you have an absolute value of x equal -8, that shouldn't be exist, right? That's no. Now let's check how to solve the following equations that has an absolute value. So the key is, remember, between those absolute value symbol bars, it can be negative value or positive value. Both will come out as a positive value. So you're gonna separate as a 2 cases. First case, x plus 3 equal +8. The other case, x plus 3 can be -8. And solve each cases for x. So this case, x equal 5, and the other one is x equal -11. The next one, 3x minus 1 equal 10. So for the x, so 3x equal, it will be 11. So x will be 11 over 3. And 3x minus 1 equal -10. So 3x equal -9. And divide by 3, x equal -3. And the next one, in this one, you see there is -2 outside of the absolute value symbol. So the first goal is you need to isolate as a whole group the absolute value, and then the other one has to be moved to the opposite side. So adding 2 on both sides, absolute value 2x plus 8 equal 16. Then you can make a 2 cases. 2x plus 8 equals 16. And solve for the x. So 2x equal 8, x equal 4. And 2x plus 8 equal -16. And 2x equal -24, x equal -12. So we will do same process on the last question. So absolute value x minus 10, subtract 10 on both sides will be equal 10. The first case, x minus 10 equal positive 10. The next one, x minus 10 equal negative 10. So one is a positive, one is a negative. So x equal 20, and second one is x equal 0. All right, if you didn't understand any of this process, please reach out to me. And if you understood and you're able to check your own mistake, that will be awesome. And let's move on to the next one. Let's review quick how you can determine what is a domain or range. So domain means all the possible value for the x. So when you're looking for the x value, what do you need to look for? That's right, your x-axis, right? So I'm just pointed out few points, but eventually, since there are lines, it has infinity of the x values that corresponding to each point. So that means since they are expanded on both sides of negative infinity to positive infinity, x value should include all real number. So if I writing as a set notation, x, all set of x such that x is element of all real number. If I'm writing interval notation, that should be negative infinity till positive infinity. If I'm writing algebraic inequality notation, x should be greater than negative infinity, less than positive infinity. So I'm just showing all different example how you can writing in different notation. However, you gotta be careful with range, especially absolute value function. Looking at the vertex right here, so the vertex is 0 and 0, and that is also minimum. What does that mean? That is the lowest value of the f of x, which is a y value. So the range has to be greater than or equal to 0. Writing interval notation should be bracket with a 0 because we're going to include 0, and going to positive infinity because this is expanded to up, right? And if I writing the inequality notation, that will be 0 greater than or equal to or less than positive infinity. The graph looks like a V shape. The turning point is called the vertex. Now let's go over how we can use a table in order to graph absolute value function. The first goal is find the x value of vertex. How you can do it? It's simple. Whatever inside of that absolute value symbol, the expression, you set that as a 0. So what does that mean? So the first question, you have a x minus 4 inside of the absolute value symbol, right? So you set up x minus 4 equals 0. And solve for the x, and that should be the x coordinate for vertex. So adding 4 on both sides, x equal 4. So where are we going to replace that? Yes, that's going to middle row of your table. So I'm going to put, this is a middle, 4 here. So if we place 4 into the original function, our y value will be 0, right? Then what is the next thing you're gonna do? So from the middle to up, you're gonna put the number, the down value, which is 3, 2, 1. And then from down to that number, you're gonna raise the value 5, 6, 7. And you plug in each x value into the original function. So when x is 3, minus 4, that is absolute value of -1, which will come out as a 1, right? And if you put 2, same process, you will have a 2 and 3. And if you put 5 minus 4, that's equal +1, so which will be just 1. And you do same process. And as you can see the pattern, you should have what? Symmetric, the numbers. If yours doesn't come out that way, there should be some mistakes. All right, so now you're just plotting that point. Let's find the vertex first. The vertex is when x is 4, y is 0, x is 5, it's 1, 6 is 2, 7 is 3, and you do 4, 1, 3, 1, 2, 2, 3, 3. Now connect those points and it will be come out as a V shape as well. So let's find the domain and range. Domain should be all real number, and range is greater than or equal to 0. Let's try one more practice on number 2. So 2x plus 6 equals 0. Solve for the x, subtract 6 on both sides, divide by 2, x equal -3. So that should be placed on the middle row. And if we plug -3 as x value, your y value should be 0. Just be careful when you have a negative value for x. You have to make sure you put it right order. The bigger number with the negative sign is a smaller, right? And this would be -2, -1, and 0. And you plug in each x value into that original function, you will get y value, and this will be 2, 4, 6. I'm skipping each to find out that value because I assume you already done as your independent work. So let's plotting the point and connect them to draw the graph. So domain is all real numbers. Range is greater or equal to 0. Like number 3, you have other value attached to the absolute value. When you're looking for x coordinate for vertex, you only need what's inside of that absolute value symbol, which number 3's case have only x. So x equals 0. So x equals 0. 0 goes in the middle row. When x is 0, you plug into the original function that will give you 5. When x is a -1, it will come out as 1 plus 5, which is 6. When x is a -2, it will be 7. When x is a -3, it will be 8. When x is a 1, 6, x is 2, 7, x is 3, 8. So connect those points to draw the graph. And the domain is all real number. Range, the minimum is when y is 5, so y such that greater than or equal to, not the 0, 5. Number 4, so set 3x plus 2 equals 0. Solve for the x. So x is negative 2 over 3. So we're gonna put negative 2 over 3 in the middle. And when x is negative 2 over 3, y value is 0. And in this case, put rest of the x value as integers, so that way we can find easily the point. So I'm gonna put negative 1, negative 2, negative 3, and instead of 1 it should be 0, then 1 and 2. So you plug each x value in order to find the y, like 3 times negative 1 plus 2, that should equal absolute value of negative 1 will come out as a positive 1. So you do rest of them, and you should get 147, and when you put 0, so that will be 0 plus 2, which will be 2. If you put 1, that will be 5. When it's 2, it's 8. So I know when it's a fraction or decimal, you gotta find that around near there. So we'll find the negative 2/3 and 0, and negative 1 to 1, negative 2 to 4, 1, 2, 3, 4, negative 3, 4, 7, right here. And 0 to 2, positive 2. I know in this point you don't see the symmetric, but once you draw the line, you will still see the V symmetric graph. So when it's 1, it's a 5. When it's a 2, it's 8. So let me draw. And some of you guys plug in the fractions. That's totally fine, as long as you have a sketch of the V symmetric graph of the absolute function. So domain, it's all real number. And the range is y is greater than or equal to 0. Number 5, you see the negative sign in front of that absolute value. So since it's not inside of the absolute value, you shouldn't worry about for looking for the vertex. You set up x plus 1 equals 0. That means x equal negative 1. So negative 1 in the middle, and that means your y value is 0, and negative 2, negative 3, negative 4. Here it goes, 0, 1, 2. So when it's negative 2, don't forget there is a negative in front, so negative 2 plus 1. That will come out as a negative with the absolute value of the negative 1, and that will be negative 1. So it's a negative 1. You do the same way with the other x value, plug in, and you should get what I got here, and then plot to graph. So this one, what's different than the other graphs that we've been drawing? It's upside down V shape. You notice when you have a negative, in front of that absolute value, that means the graph is reflect across to the x-axis. So instead of looking like this, you see what I'm saying? It's reflected across x-axis. Alright, let's writing the domain is the same, even it's reflected. X is all real number. And the range, so let's talk about range in here. So this vertex point is a minimum or maximum. So our graph is all under the x-axis. That means that point is a maximum value of y value. So the range y such that y is less than or equal to 0. All right, now let's move on to the next one, number 4. So what's inside of that absolute value is 1/2 x plus 1 equals 0. So solving for x, so x equal -1 times 2, it will be -2. So -2 is going to middle low. If you plug the -2, you will have y value as a -4. If you put -3, it will be -3.5. It will be -4, -3, and -5, -2.5. If you wanted to avoid the negative the decimal number, you can choose a different x values, but I think in half that's easy to mark on. So I'm just going as it is. When it's a 0, not the -0, it will be -3 and 1 and -2.5. So you thinking, oh, why we still have a negative numbers? Because we have -4 at the end, right? So let's find the point and connect those lines. Something like that, right? So the domain is all real numbers, and range, this is a maximum, and that's -4. So y such that y is greater than or equal to -4. Before moving on, I wanted to mention one more thing. Look at number 4 and oh, this is number 4 again. I guess that's typo. Let's say that's number 6. So number 4, this graph is a stretch vertically, so it's kind of narrow, and this one, number 6, is compressed vertically, so it's get wider. There is a reason for that, and we're gonna learn that all the transformation rules later, but I just wanted to give little heads up. So do you see the number in front of the x? Yes, that number is actually affecting those vertical stretch or vertical compression, so the graph become narrower or wider. All right, guys, I'm sure if you were able to try those independent work, you should be able to answer all these 3 questions, include some remaining question that you want me to go over. And if you have any question, please reach out to me or find another resources or review on lesson videos and asking somebody who can help you too. Then I will see you on next lessons. 안녕.